Hi, everyone. I'm very happy to be here with all of you today in this wonderful online conference, Women on Stage. Thank you so much for having me. Thank you for joining my talk. And yeah, my name is Patty Ocallaghan. I'm going to be talking about web machine learning, what can we do, and especially using this amazing open source library called Tensorflow.js. So let's start. First, I'm going to tell you a little bit about me. My name is Patty Ocallaghan. I am originally from Venezuela, but I moved to Glasgow 6 years ago. I'm a tech lead for the web team at Charles River Laboratories. I am also a Google developer expert in machine learning. I'm a Women Tech Makers ambassador, and I'm part of the organizing team at the Google Developers Group Glasgow. I am also a volunteer teacher at a code club, which is part of the Raspberry Pi Foundation. So basically, what I do is that I go to my local school 1 hour per week, and I teach kids from 10 to 16 years old how to code, and we do a bunch of machine learning projects. So it's my favorite thing to do. And if you want to get in touch with me, if you want to send me any kind of comments, or if you have any questions, just let me know. And you can scan that QR code that is on the slides. Let me hide this a little bit. Yeah. And yeah, you can get in touch with me over there. All right, so let's begin. Um, Okay, so let's get started. The first thing that I would like you to do is to go to that URL, and there you will find all the information and everything, all the steps of the project that I'm going to show you today. So basically, if you go there, this is what you will see. And first of all, I want to thank Jason Mays from Google for providing the content for this talk. And he's an amazing developer, an amazing person. So I will highly recommend all of you to go and see all of the amazing content that he's putting on online about web machine learning. All right. So this is what I'm going to be explaining to you. So you can have a more in-depth look into the content after the talk, because what I'm going to do is that I'm going to give you like an overview in each of the steps. But then if you want to read in more detail, you can go there and have a look. All right. So what are we going to do in this workshop? We are going to use a pre-trained model based on Tensorflow.js. It's a pre-trained model in Tensorflow.js, which is known as Coco SSD. And what it will do is that it will recognize people or cats or objects, whatever is 80 different objects. It will recognize it on a webcam stream, or maybe on a picture, but in this case it's going to be using our webcam, and it will draw bounding boxes around those objects, and it will let us know if it's a person or a cat or a dog or so on. All right. uh, so that's the project that we are going to be working on. So the cool thing about TensorFlow.js is that you can actually, if you have some basic understanding of web development and you know how to use HTML, CSS, JavaScript, just a basic knowledge, you're going to be able to use TensorFlow.js, and you might want to use the pre-made models that we're going to be talking about those later, and you will be able to create amazing projects. So for example, in this case, this was an app that used the same model that we're going to use today. And what they did is that they were using like an old mobile phone, and then with the camera you will select, okay, I want to detect a dog or a cat or whatever pet you have at home, and then let's say the food, and if the and then you will start the webcam stream, right? Or in this case, it's like the cell phone camera. And in real time, it can detect, for example, when the dog is very near or is in the same image, in the same video as the food, it will alert you. Maybe it can send you, I don't know, an email saying, okay, keep an eye on the dog because it's about to eat all of the cookies. So yeah, you can create any kind of very different kinds of applications, maybe for work, maybe for fun. The kids at the code club, at my code club, has been using this, and they have created really, really amazing applications. So what I want you is that for today, after seeing this talk, you can have the knowledge, the basic knowledge, and take it with you and turn it into something useful that might, I don't know, solve a problem in your life or someone else's life, of a person that you know. Maybe you can create like a smart pet feeder, and you can connect it with a Raspberry Pi. There is a bunch of amazing stuff that you can do. All right, so let's get started. So we are going to go to the first step of the code lab. So again, I will just you will see a bunch of text over there, and I'm not going to read everything like word by word, but I will just give you a summary on what we'll expect on that, what should we expect to see on that step, and all the key things that you need to know. And of course, then you can have a look at it in more detail. All right. So what is that we're gonna do? If you follow along, you will be able to build a web page. You're going to be able to use artificial intelligence in your browser with machine learning, and we're going to classify common objects using this pre-made model called Coco SSD. And we're going to draw those bounding boxes that I told you about. And what is it that you will learn? You will learn how easy it is to load a pre-trained model in your web page. How can we grab the data from the webcam stream? How can we classify all of the objects that are on that webcam stream? And how can we create those bounding boxes to make them highlight these objects? Okay, so now let's talk about Tensorflow.js. What is it? So if you go to the second step of the code lab, you will see all the information, but I'm going to give you a summary. So Tensorflow.js is an open source machine learning library that runs anywhere JavaScript can. And Tensorflow.js was created by a very amazing team in Google, and it's great that they have decided for it to be an open source library, an open source tool that we all can use and contribute to it. And one of the most amazing things as well is that it can run over JavaScript, and like it uses JavaScript. And as you know, JavaScript can run over a bunch of different devices. So that is actually very powerful, and it allows us to, like, the innovation and the things that we can do just gets bigger and bigger. All right. So what is that we can do with Tensorflow.js? First of all, it allows us to run existing models. So those could be the pre-made models that comes with Tensorflow.js. You can also create, if you have used TensorFlow with Python, which is like the original classic version of TensorFlow, like the main one, you can bring those models and use them also in TensorFlow.js. And you can also run models. These models, you can run them on the browser or on Node.js. Then you can also retrain existing models. And basically what that means is that you can use a method called transfer learning. So it means that you can create a model that someone else has made, and you can retrain it with your own data. And that can be very beneficial because the process of gathering the data and training the models, it can be very, very expensive in terms of time and money. So being able to grab a model that was already created and that can fit in certain way the data that you have, you're going to be able to retrain it and have your like a brand new model, but without spending a lot of time and money gathering your data, preparing the data, and actually training the model. That can be really expensive. Obviously, depending on what you're going to be working. What is your model about, right? And then, of course, you can create a model from scratch, and you can use JavaScript to, build your model. All right. And these are all of the environments that Tensorflow.js support. So again, because it's JavaScript, it can run in many, many, many places. So in the browser, well, there, of course, you can add many, many other browsers, but I added those three. But you can run your models in the browser. In the server side, you can use Node.js. You can run your models and also train your models. You can use mobile phones with React Native or PWA, which is Progressive Web Apps. On desktop, you can use Desktop Native via Electron. And in Internet of Things, my favorite would be with Raspberry Pi using Node again. So in all of those places, you can think about different applications using machine learning. Okay, so because we're using JavaScript, we can use the client side, right? Because we can run these models on the browser. And this comes with really nice superpowers, okay? And the first will be high privacy. And that is because all of the data that we get from the sensors, let's say from the camera, from the microphone, from the webcam, and so on, those are not being sent to a server for classification, right? So the data, all the classification is happening in the browser. Let's say in the case that we are using a browser. So everything is happening on the device of the user. And that means, of course, that the user's data stays private, right, on the device. Another thing will be lower latency, and that is because there is not a server involved in the process. It means that there is not like a round trip from the mobile phone to the server and then coming back again. Okay, so the latency is obviously lower. Then we have the reach and the scale of the web, and anyone, anywhere, no matter what the background can be, they can go and open a web page and enjoy the benefits of using a machine learning model and using AI in the web browser. And they don't need to be machine learning experts, data scientists. They don't need to be computer scientists. They can just be regular people using AI on their devices. And then the next one would be lower serving costs, and that means that because we don't need to run a server with an expensive hardware, GPUs and RAM. We can just host our model on a web server. Usually that's very cheap nowadays. It's not expensive, of course, depending on what you want to do. But let's say that for a reasonably popular website, that can actually cost you don't have to pay a lot in order to be able to deploy your model on a website, for example. And again, let's remember that you can also host this on Node.js. Okay, so I'm going to explain a little bit about the architecture of how, what are the layers that of APIs that Tensorflow.js provides. So in the top layer, we will find the models, the pre-made models, and these are JavaScript classes that are ready to use, right? You can just grab them and start using them right away. And you will see that in the code, in the project that we're going to build. Then we have the layers API, and it helps us to easily build and train a model using like higher level building blocks. And then we have the Ops Core API, and this will give us like a better control of the model architecture and the maths that are behind it. All right. So let's have a look, more in-depth look, and how this lower level API talks with the different environments. All right. So let's start with the client side. Okay. And as you can see here, we have the web browser, or it can be, for example, a progressive web app. And these environments, they can talk with different backends. And when we talk about backends, it does. I'm not talking about like server side kind of backend. This is just the TensorFlow.js backend, which is actually the hardware where TensorFlow is being executed on. Okay, so TensorFlow JS supports several different backends on the client side if we're using the web browser. So the first one would be the CPU, and every device, every computer has a CPU. Okay, so this is always available for us, but it's the slowest form of execution. Then if we want to go faster, we can use WebGL. And this is really great because it allows us to have access to the acceleration of the graphic cards. And these, we have the option of running our models on those. And obviously, these give us like a faster execution compared to the CPU one. And then we also have WebAssembly, and WebAssembly also give us is faster than the CPU, but it really depends on the size, depending on the size of your model and certain conditions. One option can be better, faster than the other. So it really depends on certain conditions that your model might have. So, but yeah, we have a very, very fast performance for the client side, right, on web machine learning. And then on the server side, like I said before, we can use Node.js. And I'm not going to go into the detail, but just for you to know that it has access to the TF CPU and the TF GPU. And all that you need to know here is that this is written in C++, and they are actually the same backends as TensorFlow Python. All right. So some people believe that you can discuss, again, depending on certain circumstances, under certain circumstances, that TensorFlow and Node.js could have like the same inference performance as Python, and maybe it can be faster because of the just-in-time compiler of JavaScript. But it's a discussion. Okay. Now let's talk about my favorite part, which are the pre-trained models. And the pre-trained models that the team at TensorFlow.js had been offering are really, really amazing. And you can do, honestly, amazing stuff. So let's have a look at it. That will be the step number 3 on the code lab that we're following, but I will explain to you what is it about. Okay, so like I said, the team at Tensorflow.js, they have been releasing a lot of pre-made models, and they are always like expanding the selection. And there are different categories. They have models that works with vision, human body, text, audio, and a more general model. And the good thing about this is that you don't really need to have like a background in machine learning in order to use them. As long as you have working knowledge of JavaScript and HTML and CSS, you can just grab them out of the box and use them, and you will see how easy this is. So what you will learn today will enable you to use all of these other models, right? We're going to use today object detection, but you will be able to use the rest of the models. So it would be nice if you can go after this and have a look around and see and play with them. Okay, so I'm just going to talk to you a little bit about each of the models. So there's one for image classification. So it will work on an image. Object detection, it will recognize objects on a frame. Semantic segmentation, it will analyze an image, and it will like separate by segments everything that it can find, and it will tag that like a person, a car, and so on. But it's like the silhouette. Then for the human body, we have simple face detection. We have face landmark detection that it can add, I don't remember how many points, but it adds like points on top of like the eyes, the nose, and a bunch of different points. And what it does is that it recognizes the position of all of those dots on your face, and that will allow it, for example, to create a filter that puts like a mascara on top of your face. It's like the famous filters that you see, I don't know, in a Snapchat and so on. Pose detection is pretty cool. It can recognize, you can train it to recognize poses that you do. So I have seen projects about yoga poses, or one of the kids at my code club did one for karate poses, and it's pretty cool. It's really, and it can be really useful. Body segmentation can recognize like where is the head, the arms, the legs. Hand pose detection is actually really good as well, and for accessibility, there has been really amazing projects with that. And portrait depth estimation can estimate the depth of a picture, of a portrait, and it's also helpful. Then we have natural language question answering. You can grab, a bunch of text and ask questions over that text, and it will reply to you with some answers. You can use it. There's another model to detect text toxicity you can use it on a chat, for example, and a universal sentence encoder. For audio, we have a speech command recognition, so you can there's like a limit of seconds that you can actually record, and it will recognize. You can train it to recognize what you're saying and follow an instruction. And then we have a more general one, which is a little bit more technical, which is the nearest neighbor classifier. And if you want to have a look at those and see how you can play with them, you can go to that URL that is on the bottom of the slide. Okay. And what are the benefits of using pre-made models? So the first one is you don't need to gather the training data yourself. And that is because the model has been already trained for you. And this is very beneficial because that step of the process of creating a model is where you can spend most of your time and most of your money. And then you have to collect the data, you have to prepare the data, and you might need to deal with a bunch of different challenges. So that's the very first amazing benefit of using a pre-made model. Then you have a rapid prototyping with lower cost. And this is achievable because, again, all of this hard work of gathering and training the model and testing the model, that's already done. So you can just start testing right away and start building your prototype right away and see if that's really what you want for your problem, or it really works for what you want to achieve. Then it uses a state of the art research, and that's because you know this is being backed by Google, and Google is always on top of the field in terms of machine learning research and AI research, and it's been great, and they're constantly working on it, constantly making it better. And of course, by being an open source library, the contributions of a lot of people around the world is making the tool better and better and better, the library, every day. Then it's easier to use, and it has very good documentation. So if you go to tensorflow.org/js, you will see all of the documentation. It's pretty clear. It's very easy to follow. And as you will see today, it's very easy to use. And then we can have transfer learning for some of the models. So you can adapt those models to work with your custom data, right? That maybe the model haven't seen before. Okay, so let's talk about the model that we are going to be using. Like I said before, it's called Coco SSD. And what it does is that it recognizes objects in an image or a video, okay? And it can recognize one or more multiple. You can have multiple objects on an image, on a video, and it will recognize it. It's been trained on a data set called COCO, which it stands for Common Objects in Context. And I think it was curated by Microsoft. And it uses the SSD architecture, which means single shot detection. So that's where the name comes from. And yes, this is the one that we're going to use. So for the setup, that you will go to page number 4 and to the step number 4, and you can follow there all of the steps that you need to do. I'm not going to do it. I'm just going to walk you through and explain the code, and then you can follow along if you want more detail here. Okay, so what I want you to do is to go to this URL, right? And there, what you will find is like a boilerplate. And you can copy that. I will show you how you can copy that to make like your own copy of that boilerplate. And then you can follow step by step what you will need to do. So let me see if I can open it here. And I will share that other screen. Okay, I'm gonna stop. I'm gonna stop presenting this one, and I will move to the next. Okay, so this is what you're going to do when you go to that URL. And basically, this is an editor online that you can work on HTML, on your CSS file, on the JavaScript files, and in this area on the right, you will be able to see on real time what you are editing, what you're working on. Okay, so you will find an HTML file, a JavaScript file, and a CSS file. This is just a boilerplate, okay? So for example, if I edit something here, it will immediately change here, okay? So this is what we're going to use. So let's go back to the slides and then we can continue. This is good that this can be done pretty quickly. All right. So that is where we are. And basically what you're going to see is that you will see when you get into that URL, you will see this remix your own button. So you just click there and you're going to create a copy and you can work over that. Okay. So the first thing that we need to do is to create like the HTML skeleton of our project. And I just want you to follow along and listen like the explanation, and then you can play and copy the code. Okay. So basically what we have here at the beginning is the basic HTML page. We have the head and we have the title, and we are going to import our style CSS file. All right, where we're going to add a bunch of stuff like a styling of the fonts and some of the elements that we're going to have on our HTML site. Okay. Next, this is like the most important part. So inside of the body, you can see that we have a section with an ID demos, and initially it has a class called invisible. And this is because we want to wait. We're going to make a certain part of the website like it's gonna be like it will seem like disabled. And what we want to do is that we don't want the user to press the button to enable the webcam until the model is not loaded. All right. So we want the model to load before we ungray everything to indicate that the user can actually interact with the page. Okay. And then we have a paragraph. I will explain later how are we going to do this. Then we have a paragraph with some instructions, and then we have a div where we are going to show the streaming from the webcam. Okay, we will have the button to enable the webcam, and then on the video tag we're going to actually show the video. All right. Okay. Then this is the most important part, which is to import the Tensorflow.js library, then the model, and then our script where we are going to interact and create what is that we're going to create. Okay. But see how easy it is to include Tensorflow.js into your website. You just have to use a script tag and add the URL to the library, which is that one that you see over there, and that's it. So first, it's very important that you follow the order. First, you have to import the Tensorflow.js library. Then you will import the model, and then you can include your JavaScript file. So as you can see, first the TensorFlow library, then the model. So the model, we do the same. We have a script tag in HTML, and the source will be the URL to the model. For you to know the URL to the model, you just have to go to the documentation the link that I showed you before in tensorflow.org/js. You can find there the pre-made models, and you will find the URLs. And obviously the documentation about the model and how to use it. And you can start from there. And then again, by the end, the script that we're going to do our custom work. All right. So as you can see, it's pretty simple. Now we're going to add the style. So like I said, if you're following along and you add the style from the website, you're copying and pasting, this is what you're going to be seeing by the end. We are going to add this gray area, like to seems that is like disabled, so the user cannot click the button enable webcam until the model is loaded. And why is that? Because if we click that and the model is not loaded yet, it will break. It will not work. One thing that is important is that the models, this model, like they're not very big in terms of size, so they can download pretty quickly. We don't have to wait like minutes or anything like that. Okay, so I think that here I would like to maybe talk to you a little bit about the CSS code. Okay. Let me share over here. Change the screen. And let's see if I can make this bigger. Yeah. Okay, so this is our CSS, and basically we are saying for the body tag, which is the font that we're going to use, the color, then we have for the headings, again, type of font, the style, the color, and I just want to show you this class invisible. So it makes the opacity 0.2. That's why it looks like great, like disabled. And then we have more styles for how are we going to see the webcam stream, and additional styling for the bounding boxes. Okay. All right. Let's continue to the slide. All right. So this is how you should be seeing. And now let's talk about the JavaScript. Okay. What is it that we're going to do? So, of course, we have now the styling, but we need like the behavior. How are we going to make this work? How are we going to start the webcam and start like recognizing all of the objects? So you will read all about that on the step 7 of the code lab, but I'm going to go through the code to explain to you what is it about. So first of all, it's very simple. We're just defining referencing elements that we have on our HTML page, and we're referencing them in order for us to be able to manipulate them within our JavaScript code. So we have the one for the webcam, for the live view, which is the div that we just talked about, for the demo section, and the reference to the button that will enable the webcam. All right. Okay, then what we are going to do is that we define a function called getUserMediaSupported. And what this function is going to do is that it will check if the web browser that the user has supports accessing to the webcam. Okay, but nowadays, most of the browsers have that kind of access, and it will be very weird if not, but we need to check just in case it's disabled or something is wrong. Okay, so what we're doing here is checking if we can have access to the functions that work around the webcam, let's say, and we want to check if we have access to those functions and the objects. So that's going to return true or false, and depending on that, we can continue executing the script. Then if the webcam is supported, what we do is that we add an event listener to the button enable webcam, okay? So the event is click. So if that button is clicked, then we are going to execute the function enable cam, okay? And if we don't support if the webcam is not supported, then we will print a warning on the console that says your browser doesn't support access to the webcam. Okay. So now let's talk about the function enable cam over here, which is the one that is going to be executed if the enable webcam button is clicked. Okay. So this is our function. The first thing that we're going to do is to check if the model has already loaded. So if the model is undefined, we're going to return straight away, and we're not going to execute any of the code that is after it. But if the model is defined, it means that the model has loaded, then we can continue. And the first thing that we're going to do is that we are going to add a class to our button to the button that was clicked. And what we're going to do is to add that class that is removed. And what it's going to do is basically remove the button from the view. So as soon as as soon as the model has been loaded and the user clicks the button, it will disappear, all right? Then we are going to pass something called the constraints. And what we're going to say is that we want to use the video, okay? And not the audio. Because if we use the video and the audio, it will create an echo. And we don't need the audio because we just want to recognize images, right? So we're saying, okay, for the user media, we want to get the webcam stream, and I just want to get the video, not the audio. And then that stream that we're getting, when we activate the webcam stream, that stream we are going to add it as a source to our video element that we have on our HTML page, okay? And we will add another listener, and is that when the data has been loaded on that element, we want to execute the function predict webcam, okay? So what is that function about? That is where everything happens. Okay, so we have here a placeholder for predict webcam, and right now it doesn't have anything. So if you follow along the instructions on the code lab, what we want to pretend is that the model has been loaded, and we want just to check if we can actually get the video. All right. So we say okay, model is true. So we're pretending that the model has been loaded, and then we will remove that invisible the class. We are removing that as well. And if you are following along the steps, you should be able to see yourself. And you have the camera in front of you, you will see yourself in real time, like a video. Okay, this is obviously a still image, but yeah, you will see yourself in a video. Okay, so that would mean that it's working. And now let's use TensorFlow. Okay, so this is like the exciting part, and we are going to interact with the model. So that will be a step number 8. And let's see how this works. So the first thing that we are going to do is to define a variable called model, and we're going to set it as undefined initially because the model has not loaded when the page is loaded. So of course, the next thing that we need to do is to actually load the model, okay? And to do that, we just can simply call Cocoa SSD load. Remember, you included when you included the Tensorflow.js library, then you included the model. You can use that class right away out of the box. So we're using that to load the model. And this is an asynchronous function because the Cocoa SSD model is just a few megabytes in size. So we need to wait until these depending on the internet connection of the user, we need to wait until that the model has been downloaded. Okay, so for that we use an asynchronous call. Okay, to wait for it to finish. So when it has finished, it's going to call a function, and we are just passing a single parameter, which is the loaded model. Okay, and the loaded model, we are going to assign it to our variable model. And now that the model is loaded, we can remove that invisible class. Okay, then we have an array that is called children. And that array, what it does is that every time we draw a bounding box, it will add like a square, like the box, on our DOM, on the website, right? On the image. It will paint it on the image. But if we don't remove it, it will stay there. And if we move, for example, like the box is going to move with us and we're going to be painting a bunch of boxes. And if we don't remove them, all of those boxes are going to stay on the video, like on the screen. So this array for children array, what we do is that we grab the information around those boxes, we put it there, and then we remove them. So we can know, like, okay, this is something that I need to remove. Then every time the frame refreshes on the video, we're going to remove all of the bounding boxes that are on that children array. Okay, then we're going to create a function called the predict webcam. And this is a function that's going to be executing like on the animation loop and on the frame loops, which are the videos, and it's going to keep predicting again and again and again for all of the frames that are coming back from the webcam stream. All right, and it's going to execute the machine learning model. Okay, and then what it does, the first thing that it does here is, of course, to do the prediction. And notice how the Tensorflow.js code for this is just one line of code for the prediction. So most of the code that we have written so far is to deal with how to grab the webcam stream and hiding stuff in the styling. But to actually do the prediction, it's just that single line of code. And what we do is that we call the model, the text, we pass the video, right? And then we want the prediction. And what we're doing here is to add, we want to remove from the live view all of the elements that are on the children array, which are all of the bounding boxes. So that will execute depending how many bounding boxes do we have per frame. And for those of you who don't know what bounding boxes are, they are essentially rectangles that are being drawn around an image. And to define one of these, we just need 4 pieces of information. We need the top left, XY coordinate, we need the width and the height. So on the prediction of the model, it will recognize an object and it will give us the name of the object, which is the class name, and it will give us all of these coordinates to draw the bounding box. It will also give us like a level of confidence, a number of confidence that will let us know how sure it is that that object is actually, let's say, a human. All right. You will see it working very soon. And what we're doing here is to use all of that information that we're getting from the model, the name of the class, which is the name of the object, the bounding boxes, and the confidence level, and we want percentage, and we want to show that on top of the bounding box. Okay, and that is what we're doing here. The predictions here, this is an array, and we will have the size of that array would be the number of objects that the model can recognize in the webcam stream. Okay, so this can be 5 objects, and then what we have to do is to iterate over that array. And what we're doing here is that and we can play with the score. Like we're playing with the score. The score is the level of confidence. So we're saying, okay, if the score for that object is 66, it means 0.66 is, we can say 66%. It's like we are 66% sure that that object is actually what the model is saying it is, right? So we can play with that. Maybe we don't want to draw the bounding box unless we are 95%, like the model is 95% sure that that object is a cat. Or we can put it like really, really low, and we can just say like show everything that, and the model might be wrong, might be recognizing a weird image as a, I don't know, as a cell phone, and it's not a cell phone. So we can play with that. So here, just for it's an arbitrary number, we selected 0.66. And then we're going to create a p element, and what we're going to put inside there is the name of the class, which will be, let's say, human or person, with the level of a score. So it can be person with 66% of confidence. And what we're doing here is using the bounding box coordinates to be able to draw where to place that paragraph, like that element that we just built up. Okay. If you play with it, you can play with the code, and it will be easier for you to understand how it works, because you can play with it and you will see how it moves. Okay, then what we're doing is we are creating like a highlighter, and the highlighter is not like the actual box, but it's like a layer on top with a color that will highlight the object. Okay, and that is what we're doing here. And then what we're doing is that we are adding the highlighter and the that string on top that says the name of the object and the percentage of confidence and so on. And we are also not only showing that on the frame, but we are also grabbing those elements and pushing them on the children array, because we want to remove them later for the next frame. We don't want to show them again. All right. So this is what we have to do to draw the bounding box. And then what we have to do is to call the new frame. Like when we receive the new frame from the website, from the webcam, we want to call the predict webcam function again, because we want to predict what we have on the new frame, because maybe a dog appear. Now we want to predict that. Okay, and that's it. That's everything that we need to do. So what I'm going to do right now is to test it with all of you. But if you are following along, you will be able to see it working if you're using Glitch, and you can play with it. So as you can see, it's very easy. We just needed 3 lines of code for the machine learning part. The rest of it was like drawing the bounding boxes and checking if the browser actually has access to the webcam. So it's pretty easy, and you can do many different stuff with Tensorflow.js, many fun things, and that's how easy it is to use machine learning on the browser. All right, so let's test it out. I have it ready here. So let me share my other screen. Is this one? Okay, so I have this one ready. I think it's this one. I'm gonna refresh it. Let me put it smaller so we can see. So if you see here, I have the HTML code that I show you on the slides. This is all of the code that I explained to you bit by bit. This is the predict webcam function and the styles that I showed you before. So now I can enable the webcam. Okay, and here I am. And as you can see, it's saying that I'm a refrigerator, but probably it's because of the things that are on the back. There's a lot going on in my background. So for example, right now I was saying that I was a person. Yeah, I think it's recognizing the door. If I go this way, I saw over there like it said person. Ah, yeah. If I move like this way, it says a person, but it's recognizing the door. Let me check. I don't have my cell phone here. Let's see this bottle. See if it recognizes it. It's kind of a weird bottle. Or let's see this. Remote. Oh, it's a little bit, yeah. It might be the browser because it's showing the bounding box way farther than the actual object. So this, like the bounding box should be a little bit, should be over the object, but maybe it's because I resized this. Let's see if we can. I will reload it. But yeah, you can test it on your end, and it really depends on what you're showing around. Let's see. Let's wait a little bit. Okay. Let's see if now. Where is my mouse? Okay, let's see. Still thinking that I'm a refrigerator. I know I have to lose some weight, but that is kind of rude. Okay. Yeah, it's we have a problem here with the styling. So it's thinking that this is a remote, but it's moving the bounding box. Probably it's because we're using this preview panel. Probably if we use like a proper, not the preview panel, that the styling will work better. Let's see a pen. I have one here. A TV. I think it's recognizing the stuff at the back. Now I know that for the next time that I run this workshop, I shouldn't be using this background. Obviously, if I use a white wall, would be better. Okay. But it's good. It's recognizing. It's trying to recognize a bunch of stuff that is on the back. Okay. So let's finish because we're almost running out of time. And let's continue here. Okay. So I hope that you were able to make it work. Please share it with me on social media if you did it. It's always fun to see what people have been doing using while they follow this workshop. So feel free to share it. So yeah, what's next on the step number 9 of the Code Lab? You will see additional information, a recap. So what is that we learned? We learned the benefits of using Tensorflow.js, how easy it was. We created a website. We prepared the HTML, the JavaScript, the styling for it. We were able to detect and enable a webcam stream. We loaded Tensorflow.js, the library. We loaded the Coco SSD model, and we were able to create our own custom code to draw the bounding boxes and to play with it. It will be all. So thank you so much for listening. I hope that you enjoyed the session. If you want to learn more about TensorFlow.js, you can follow the website. You will read more about, you can find there more about the pre-made models. And I will highly recommend you to follow the hashtag made with TFJS on social media, on YouTube, and also on Twitter. And you will find the amazing stuff that many, many people around the world are creating, not just web developers, people that may have other kind of professions, but they have a working knowledge of HTML and JavaScript, and they have been creating amazing stuff. And you will find also a playlist on YouTube. And that will be all. Thank you so much for joining me. And yeah, reach out to me if you have any questions. See you later. Bye bye.